Okay, so imagine this. You're trying to get into your office building, right? But the security badge system is completely on the fritz. Total chaos. And someone figures out how to use that chaos to slip past security and just waltz right in. That's kind of what we're diving into today. A critical flaw in GitHub Enterprise Server that until they patched it recently, lets someone completely bypass authentication.
Yeah, and this wasn't just like, you left your badge at home. This was a really serious vulnerability. We're talking about a 9.5 CVSS score, which is almost unheard of. To give you an idea, anything above a 9 is considered critical, meaning someone could completely take over a system.
Yikes. Okay, so not your average software bug then. And this one targeted something called SAML single sign-on. I feel like I've heard of that, but maybe some listeners haven't. Can you walk us through what SAML is and why a flaw in it is such a big deal?
Yeah, so SAML, think of it like a master key to your digital life. Like say you use it to log into your company's network. Instead of entering a separate username and password for every single app you use, SAML lets you just log in once and then boom, you have access to everything.
Okay, so it's super convenient. But I'm guessing like any master key, if it falls into the wrong hands,
Exactly. This vulnerability exploited a flaw in how GitHub Enterprise Server or GHES uses SAML, specifically a feature called encrypted assertions.
encrypted assertions. Okay, that sounds serious. Break that down for us. What's actually being encrypted, and is this something that like everyone using GHES needs to be freaking out about?
Okay, so good news first, this wasn't enabled by default, but it is a perfect example of how even like small configuration choices can have a huge impact on your security.
Oh, wow, okay.
So encrypted assertions add like another layer of protection to the whole SAML process. Imagine your login info is being passed between like your identity provider and GHES. Encryption basically scrambles that info while it's traveling over the network, making it way harder for someone snooping to make any sense of it.
Okay, so even if someone was like listening in, they wouldn't be able to steal your credentials with this encryption in place. But what you're saying is that this flaw meant that even with encrypted assertions turned on, someone could still get in.
You got it. An attacker would need network access, though. It's not something they could do from miles away. They'd need to be in a position to actually intercept that data being passed back and forth. Like if someone was physically like tapping the communication lines.
Okay, so a slightly more elaborate heist than just like guessing someone's password.
Right.
But still really concerning, especially since I read that this flaw was what did they call it? A regression.
Yeah, that's right. It basically means that GitHub had actually fixed a very similar vulnerability before, but it accidentally got reintroduced into the code. It's like patching a hole in your wall only to have it reappear when you repaint.
Oh, no.
Yeah, it just shows how even with the absolute best intentions, software development is so complex, and security really requires everyone to be constantly on their toes.
For sure. It's a good reminder for everyone that cybersecurity is not a one-and-done deal. It's a never-ending process.
And speaking of ongoing, I heard that this wasn't even the only security update GitHub released. There was another vulnerability they addressed at the same time. A little sneakier, though. What can you tell us about that one? Right. So this one was a potential information disclosure flaw. It's tracked as CVE 20.024.9539. And while it's not as high impact as that SAML issue, it just highlights how creative attackers are becoming and how they can weaponize even files that you would think are totally harmless.
Okay, I'm intrigued now. What kind of files are we talking about here?
So picture this. You get an image file in your email.
Yeah, happens every day.
Right. You're probably not thinking twice about clicking on it.
I mean, unless it's from a totally suspicious email address.
Of course, good digital hygiene is key. But this vulnerability involves something called malicious SVGs. SVG stands for Scalable Vector Graphics, which is just a type of image file.
Right, so it's just an image. What's the big deal?
Well, these SVG files can actually be made in a way that when you open them, or sometimes even just load them in your browser, they can actually steal your information.
No way, really.
Yeah, so in this case, an attacker could have potentially gotten their hands on some user metadata by tricking them into clicking a link to one of these malicious SVGs.
Okay, hold on. Remind me what metadata is again? It's like data about data, right?
Exactly. Think of it as like the behind-the-scenes info about a file. In this case, it could be things like usernames, file paths, or other details that could be valuable to an attacker.
And this vulnerability meant that just clicking a link could have exposed all that.
In theory, yes. If the attacker found a way to actually upload these malicious SVGs to a GHES instance and then tricked someone into clicking a link to that file,
Right.
I mean, it's a little convoluted, but it just shows how far these attackers will go and how important it is to have multiple layers of security.
Okay, so we've got these two vulnerabilities in GitHub Enterprise Server, and obviously anyone listening who uses GHES, you're already updating your systems. But this whole thing got me thinking, even if software vulnerabilities are found and patched really quickly, security isn't just about the code itself, right?
Yeah, you hit the nail on the head. It all comes back to the human element. Like, you can have the most secure system in the world, but all it takes is one person clutching a bad link or falling for a phishing scam, and boom, everything's compromised.
Right. It's like leaving the back door to your code repository wide open, even if the front door is, like you said, totally bolted shut.
100%. And that's why I think education is just as important as any software patch. Everyone, from the developers to the project managers, they all need to be aware of these common cybersecurity threats. We're talking phishing emails, social engineering tactics, even just understanding good password hygiene can make a world of difference.
Because at the end of the day, humans are the weakest link.
Sadly, yeah, oftentimes they are. Attackers know this and they take advantage of it. It's like you wouldn't walk through a dangerous neighborhood at night without being aware of your surroundings, right? You'd be cautious, you'd be alert. The digital world is no different.
So true. You got to be just as aware of your digital surroundings as your physical ones.
Exactly. And that means staying informed about the latest threats, practicing that good cyber hygiene, and thinking twice before you click any links or share personal info online.
Which, of course, is why we do this deep dive in the first place. But you know what we haven't even touched on yet? How these vulnerabilities were actually found. It's so easy to just, take these security updates for granted. But there are real people behind the scenes making that happen, right?
Absolutely. There's a whole world of behind-the-scenes work, and it's honestly fascinating. In this case, those GitHub vulnerabilities were actually found through something called a bug bounty program.
Bug bounty programs. Okay, tell me more about this.
Basically, companies will incentivize security researchers to find and report vulnerabilities to them. So in this case, GitHub has this program, and they're essentially rewarding ethical hackers for doing what they do best, finding weaknesses before the bad guys do.
It's like a digital game of hide and seek, but the stakes are way higher.
That's a great way to put it. And these programs are so valuable for companies like GitHub because it lets them tap into this global network of expertise. It's like crowdsourced security testing, which means they're way more likely to find vulnerabilities that they might have missed on their own.
That makes a lot of sense.
Yeah.
And I imagine it's a pretty exciting gig if you're the one finding these vulnerabilities.
It can be,
Yeah.
for sure. There's definitely a thrill of the chase and knowing that you're making the internet a safer place for everyone. But it also highlights something we've been talking about. Security is everyone's responsibility. It's not just on these big tech companies. It's not just about firewalls and antivirus software.
It's about everyone being aware, being vigilant,
Hmm.
reporting suspicious activity, and making sure we're not accidentally leaving any of those digital doors open.
Yeah, exactly. It's a team effort.
It really is.
Yeah.
So how do these bug bounty programs actually work in practice? Who are these ethical hackers, and how do they even go about finding these vulnerabilities?
That's a great question, and one that we should probably dig into a little bit more after we come back from this quick break.
So before the break, we were about to step into the world of bug bounty hunters. It's not something most people think about, but it's definitely important. So give us the inside scoop. Who are these ethical hackers, and what's their process like?
Yeah, so, it's not quite as glamorous as Hollywood might make it seem, but it's definitely a field for folks who love to solve puzzles and break things. With permission, of course. These are skilled security researchers who understand how software works at a very deep level, and maybe even more importantly, how it can be manipulated.
So they're not just randomly typing in code and hoping for the best.
Oh, no. There's a real method to the madness. They do systematic testing and analysis. They might start by looking at the documentation of a program like GHES, trying to really understand how different features work together, especially the ones that handle really sensitive data. Then they'll start poking and prodding at those features, trying to find any unexpected behavior or edge cases that the developers might have missed.
Edge cases, meaning those really unlikely scenarios that most users would never even encounter.
Exactly. Think of it like stress testing a bridge. You're not just driving cars over it normally. You're pushing it to the limit to see how much weight it can handle, where the weak points are. That's what these researchers do, but with code.
Okay, that's a good analogy. And so when they find one of those weak points of vulnerability, That's when they report it through the bug bounty program.
Yeah.
What happens next?
So that's when what's called the responsible disclosure process kicks in. The company, in this case, GitHub, they'll verify the vulnerability, assess how serious it is, and then hopefully get to work quickly on developing a patch to fix it. And often the researcher will actually work with them during that whole process, providing details and making sure the fix actually works. So it's really a collaborative effort.
That's really interesting. And all of that's happening hopefully before any bad actors stumble upon that same vulnerability.
Exactly. It's a race against time, and the stakes are high. Which is exactly why these bug bounty programs are so valuable. They provide a structured and incentivized way for security researchers to report vulnerabilities and then work directly with companies to get them fixed before they can be exploited.
So it's this whole ecosystem of ethical hackers, security researchers, and these big tech companies all working together even though they might not always be on the same side.
Exactly. And I think it highlights the fact that security really is everyone's responsibility. It's not just up to these companies to build perfect software, and it's not just about having the best firewalls or antivirus software. It's about awareness education and a good dose of healthy skepticism.
You've got to be aware of the threats, think critically about the links you're clicking, the info you're sharing online, basically just doing your part to stay safe in the digital world, which, as we've seen, is always changing.
Always. And, while vulnerabilities like the ones we talked about today might seem kind of scary, they also show that the system actually works. You've got the GitHub security team, these ethical hackers, bug bounty programs. They're all doing their part to try to find and fix these threats.
That's a good point. For every vulnerability that's found and fixed, there are probably others out there. But it's not about living in fear of those threats. It's about understanding them and taking precautions.
100%. And I think that's a perfect note to end on. Cybersecurity isn't about being perfectly secure. It's about managing risk and always adapting to the threat landscape as it changes.
Well said.
Oh.
So on that note, we'll leave you to ponder all of that. This GitHub Deep Dive has been a wild ride through software vulnerabilities, ethical hacking, and the never-ending challenge of staying safe online. Until next time, everyone stay curious, stay vigilant, and remember knowledge is your best defense.